Hello and welcome. Today we are doing threesome from LeetCode. We've done twosome before and twosome 2, so we have moved on to threesome. It is a medium. We're going to jump right into this one. Given an integer array nums, return all the triplets, so nums of I, nums of j, nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums of I plus nums of j plus nums of k equals 0. Notice that the solution set must not contain duplicate triplets. So we want to return unique sets of triplets where the sum of all the triplets is 0. And example 1, we have the following input nums -1, 0, 1, 2, -1, and -4. Here the distinct triplets that sum up to 0 are -1, -1, 2, and -1, 0, 1. Notice that the order of the output and the order of the triplets does not matter. Example 2, no triplet we could form can actually sum up to 0, so we return the empty list. And example 3, the only possible triplet we can make is of all zeros, so that is what we return. Okay, so we want to return a set of unique triplets where every single triplet equals 0. So let's say we had the following example. Now I want to return sets of triplets that sum up to 0. I don't care about the indices or anything else. I just want the values that sum up to 0. And I want all the values or the triplets to be unique. Now, a brute force approach that comes to mind is to make all combinations of triplets, see if they sum up to 0, and add them to a list to return at the end. But while adding them to the list, we have to make sure we haven't seen that triplet before, so we need to make sure it's unique, because we don't want any duplicate triplets. But making those checks to see whether or not it already exists in our list would be very inefficient. So how do we address this duplicate issue? Something we could do is keep track of how many numbers we have how many times. So in this example, how many -2s I have, how many zeros I have, and how many 2s I have. One way to do this would be to actually go ahead and sort our list. So if I were to sort this list, I would have -2, -2, 0, 0, and 2. Now I know how many of each number I have. And I know if I want a triplet, I would want 3 numbers that sum up to 0. So say I had 3 numbers, A plus B plus C. Now I want to pick in this nums 3 numbers that would give me 0. Say I am iterating through my list and my first A is over here, -2. Now I want to look for a B and C in the remainder of the list that when added to A would give me 0. So B and C should equal 0 minus A. So I'm looking for B and C that sum up to 2, because altogether it would give me 0. Now if I'm looking for 2 numbers in a sorted list that sum up to target, we've already done that. That is twosome 2, and I've linked it down below if you want to look at that more in depth. But essentially what happens is if we have a sorted input list and we want to look for 2 numbers that sum up to a specific target, we can leverage the fact that it is sorted and have 2 pointers at both ends. So this is my left pointer and this would be my right pointer over here. What I want to do is I want to check the sum of this. This is 0 and I am looking for my B and C to be 2. Now this is less than the 2 that I'm looking for, so I can increase my sum by moving my left up. This is sorted in increasing order, so moving my left pointer up would raise that sum. So I'm going to move left over, and now I would check what my left and right sum up to. Now it equals 2, so I've found the B and C that I want, and I'm going to keep checking up until I converge in the middle. So what we're going to do is we're going to iterate through our entire list, setting A to be all these distinct values. And we're just going to perform twosome 2 on the remainder of the list. And any number that I have seen before as I iterate through, so if my A now becomes -2 as I iterate through, I would skip because I've already seen it. Okay, so now we're going to go ahead and code this up and run through an example after. Okay, to code all of this up, the first thing I'm going to do is initialize an empty list that I will return at the end. Now I want to go ahead and sort my input num. So if I had this input, it would now become this. What is next? Next, I'm going to be setting my A value. So for I in range length of nums, I'm going to be iterating through nums and setting that a value to be every single value here. In the beginning, I will have a being at index 0. So now I want to perform toSum on the remainder of the list. So toSum on the remainder of the list. To perform a toSum, I would want left and right pointers after my a. So L is going to be I plus 1. It starts after whatever my I is, and R is going to be the end, so length of nums minus 1. While they don't meet in the middle, so while L is less than R, I want to check what my current sum is. So what is my total right now? That is going to be nums of I plus nums of L plus nums of R. Now, if this total is greater than 0, that means we want a smaller sum. So I'm going to be moving my R in. So R minus equals 1. So what is our sum right now? It is -2, and 2. If we add all of that together, we get -2. So total is actually less than 0. So if total is less than 0, then what we want to do is move our left pointer up to increase our total. So L plus equals 1. So in this case, L would be up here. Else, if our total equals 0 exactly, then we would add our numbers to the return list. So return.append, we're going to be adding a list. So it's going to be nums of I, nums of L, and nums of R. So we've just added this triplet, and now we want to continue looking for more triplets. So I will be going ahead and increasing my L value. This right now gives me a total of 0, -2, 2, and 0 is the correct total. So now I want to continue going down and making more triplets. Well, once I get down here, I see this 0 again, right? So I can't just increase L. What I want to do is continue increasing up until I come across a unique value. So I'm going to be looping through. So while my left is less than my right, and I have the same value as before, so nums of L equals nums of L minus 1, I'm going to keep incrementing my left. So L plus equals 1. So right now, this is the same value that I had before. So I'm going to be moving my L to be up here. And once we go back in this while loop, left is no longer less than right. So we exit this while loop and we go back into this for loop. So A would be here, and we would reset our right and left pointers. So left would be here and right would be here. But wait a second, we've already seen -2 at A's position, so we'll be redoing a lot of the triplets. So we also want to skip an A value we've seen previously. So what I'm going to do is if nums of I equals nums of I minus 1, if it's the same value we've seen right before us, we want to skip it. And this wouldn't work if we were on the 0th index because we'd be checking 0 against the last element, and we don't want to do that. So we also want to make sure we're not on that very first index. So if I is not equal to 0 and nums of I equals what we had before, we would continue. And continue just breaks the for loop to then restart again. So now we've taken care of all the duplicates we will see, and we formed all the triplets that sum up to 0. All that's left is to return our list. So return our list, and we can go ahead and run this code. It's accepted, and we can go ahead and submit. And it is accepted as well. So talking about time and space complexity. For time, we first sort through our nums, so that is going to be n log n. And then we loop through nums, so we will be looping through nums. And every time we loop through the nums, we will be going through nums again. We set our left and right pointers to be the length of nums basically, and we're going to be going through that again. So every time we do that, we're going through our length again. So that's going to be n squared. And then we finally return. So overall, we have n squared plus n log n. So the final time complexity would just be O of n squared. We take the bigger one overall. For space, assuming we're sorting in place, we're just keeping track of 2 pointers. So that's going to be constant space O of 1. Now, before leaving, let's just run through a super quick example. Okay, say I had the following input nums 5, -12, 5, 6, 6. The first thing I'm going to do is initialize an empty list and then go ahead and sort my nums. So to sort this, I would move the 5 over here. And for I in range length of nums, I start I over here. I is equal to 0, so we don't go into this if. Now we initialize our left and right pointers. So left and right pointers will be over here. I is 0, left is 1 over here, and right is at the end over here. While left is less than right, which is true, I find what my total is. So total is going to be negative 12 plus 5 plus 6, that is negative 1. This is less than 0, so I move my left up by 1, which means left is now 2 over here. I am back in this while loop. This condition holds true. What is my total now? It's going to stay the same. It's negative 1. So I move left up again by 1. It is now at index 3. And here, what is my total now? Negative 12 plus 6 plus 6 is 0. So I go into this condition and I append it to my return all the numbers I have seen so far. So nums of I is negative 12. Nums of L and R are both 6. Now I increase L by 1, so L is now 4, and it moves down with R. Now going into this while loop, while left is less than right, it's not true, so we're not in this while loop, and we go back into here. This is also no longer true, left is not less than right, so we are out of this while loop, and we're back into the for loop. So now I is 1, we move this down over here, and we check if we've seen this nums before. We haven't, so we're good to go, and we reinitialize our left and right pointer, so it's going to be 2 and 4. And now we check what our total is. Adding all of this up together, we're going to get 16, which is of course greater than 0. So we're going to move our right down by 1. So right is moving to 3. And we're back in this while loop. Again, the total is greater than 0. It's still 16. We move right down and we are back in this while loop. So right move to 2. We're back in this while loop. It no longer holds true. We go back into our for loop and we move I to be index 2. Now, once it's at index 2, we know that this is an I we have seen before. So we're going to hit continue and we're going to go back into the for loop. So now I will be at index 3. At index 3, we set our left and right pointers again. So left is going to be 4 and right is also going to be 4. And we go into this while loop, while left is less than right. That's not true, and it makes sense, right? Because we can't really form triplets with anything after us. There are not enough numbers to do so. So we would exit this while loop, and we're back into this for loop. So now I equals 4, and once it's here, we would make a check, and we actually see that we've seen this number before, so we would exit, and we would finally return our result, which is just a triplet of negative 12, 6, and 6, which sums up to 0. So that is how to do a threesome, and we've done twosome before, so if this seemed a little challenging, definitely go watch those videos before looking at this one again. If you have any questions at all, of course, let me know down below, and if you like this video, give it a like, comment, and subscribe, and as always, I will see you in the next one.